Hello, good morning.
Yes,
I'm David, product manager at Scaleway, and I'm taking care of the load balancer.
yes. Hello, everyone. I'm Alexander. I'm product marketing manager on Kubernetes product, but actually as well on network product. So load balancer is a part of my portfolio too. So today we have an interesting topic, configuring load balancer for your Kubernetes application. So we'll do it together with David. So if you have any question, as Nera mentioned, feel free to comment in the chat. You have a section dedicated for that. And let's get started. So the schedule for today, we'll do a short presentation about Scaleway because some of you don't know us. So it's a good occasion. Then we'll do quite a good overview about the concept of networking on Kubernetes, on load balancers, on a bit more. David will do a live demo. The best things to do is to have a live experiment and then a Q&A if we have time. I hope we have time because we have a very dense agenda. So yeah, we'll start with Scaleway. Sorry, I mixed my slide. Yes, about Scaleway. Who we are. So we are a cloud provider. Sorry, I mix my notes. We are a member of Iliad Group, a French telco company. We are about 600 persons in total. Actually, we are a quite old company, 20 years old, and we provide three different services: private infrastructure, colocation, dedicated servers, so you just rent a server at us, or a public cloud called Element. And currently, we have a big focus on that. And we own 7 different data centers in Paris, in Amsterdam, and Warsaw. We have 3 different locations in Europe. So we have on public cloud, we have everything about compute, storage, networking, and IoT. Some good family. We have more than 40 products. Everything about containers is a topic of today, but as well database or networking, serverless are part of the portfolio. Lately, we just released IAM as a new product, and we'll do normally a public beta about Secret Manager for Kubernetes next month, and VPC as well with Kubernetes. So we have many new products to come, and feel free to try. We're always happy to have feedback from you. About our Kubernetes ecosystem, that's the focus of today. We have 3 main products. Kubernetes Capsule is our managed Kubernetes. Kubernetes Cosmos is our hybrid cloud orchestrator, so you can deploy it everywhere as you wish. And the container registry is a place where you host your containers, your image. Sorry. So Kubernetes and load balancer. Let's get to the topic. So with David, we prepare the webinar, and we really wonder if we wanted to give you a full topic with all the things included about the network, or something quite easy so everyone can understand. And we decided to go really into details and give you really the big pictures of everything. So let's be ready. You will have many information today. I hope you will enjoy all the content we've done so for you. It will be valuable for your experience. Kubernetes, sorry. Kubernetes today. So a short reminder about architecture. What is it at Scaleway? We have our control plane. If we describe it, all the components, we have the control plane that's kind of the brain of the Kubernetes architecture, doing the auto-scaling, auto-healing part. Then we have our node that's control where the pods are. On the pods is typically where the containers. And besides that, we have the block storage for the persistent data, and at the end of the chain, our load balancer. And that's where we want to focus. But that's I just present you an engineering perspective, but from the client side. If we want to see that as a client, we'll not use directly a capsule. We will use your domain, connect to the domain. So we'll have a DNS resolution and then access to your load balancer, redirecting the traffic to your pods. So that's why it's very important to know how to configure it properly, because it's the main gate of your application with a Kubernetes infrastructure. So let's get started. Sorry, I'm confused with Livestorm. How to expose my application with Kubernetes? How to do that? We'll go with different concepts. And the first one to understand is a cluster IP service. A cluster IP service is a set of pods behind a unique IP. It's called actually the cluster IP, and it will have a domain name as well. It typically enables the traffic between cluster, and it balances as well the traffic between the pods. For example, in our diagram here, we have the blue service. And blue service is our cluster IP. And for example, the pod number 4 in green want to have access to our blue service. Typically use the cluster IP, and then it will balance the traffic between the pod of our application between node 1 or between node 3. It's a good thing. So we have an internal load balancer, kind of, but it's only internal, and we don't have external access. For that, we'll use another concept called the node port. A node port is actually a Kubernetes service. It's the way to expose easily a service with Kubernetes. So you have an IP address, and you can choose your protocol, HTTP, for example, and it will forward the traffic to the pod. So in a diagram, here we can see our user can have access to our application, to our pods, thanks to the range port, to the port 32567, and the blue services is accessible from the outside. It's important as well to mention that in a cluster, each node supports the node port. It's a bit complicated, but imagine the service behind each node pod as a concept. At the end, your application, your blue service, is accessible from the outside. But is it important to understand node port properly? Because node port is actually made for intra-infrastructure network. So a typical use case, for example, you have different components of your infrastructure. They need to speak with each other, but they need to use the external traffic, and you can use a node port for that. You don't need a load balancer. It's easy as well to use it for test environment or even a low traffic application. As a node port is difficult to scale because as a node port you bring a single point of failure. You can avoid this behavior having more different node, but it's more work for you to configure. So maybe not the best solution. And a second big misadvantage, in our opinion, it uses the 30,000 range, and it's not very common to expose with this range, with this port. And so the firewall will not like it. So in an internet exposition, it's not the best way to do that. So that's why it's interesting to have a look on a load balancer. It will bring a new advantage. So with a load balancer, you have actually a single entry point. You have one IP address, as I just mentioned. You can choose the protocol you wish, a very common one, TCP, HTTP, or maybe another one. And then your blue service is behind our load balancer. Our user uses the balancer to go through the infrastructure. But in that case, you need to do the configuration on the configuration of the routes, the rules, all by yourself. You need to do manually. There is a good thing with Kubernetes. There is some magic. And as a cloud provider like Scaleway, we can help you to have a load balancer. As you create a load balancer service, so it's a service of Kubernetes, your cloud provider creates automatically a load balancer for you, thanks to something we control, named the Cloud Controller Manager. And we made a service layer 4. And at the end, you have something managed and automatically configured in front of your Kubernetes infrastructure. No worries, David will show you how it works, but this is how it happens. And we've seen this concept, but in the reality, as you can guess, we don't want to expose only one service. Very often, we have more than one application in our cluster. We want to expose a website, for example, boot service could be that, but we also have an API, a SaaS application. We can have also a blog. So that's kind of example. And so far, our diagram are only with a single application deployment. So if you have more than one, there is one option. You can have one LB, one load balancer in front of each application you want to expose. But it's a lot of work and it could be costly because each time you need to buy a new load balancer. So there is one final component to present. It could be useful for you called Ingress. And Ingress is actually a resource inside your Kubernetes infrastructure that deploy a load balancer on a layer 7 on each application you want to expose. So that's something very interesting because you can have a configuration based on rules and you have more advanced network settings. There are many common names like traffic, Nginx, or HA proxy. And you can use, for example, in our console, in our API as well, application library to deploy it directly inside your Kubernetes infrastructure. So it's very easy to do it with us. So we've done many different concepts, actually 4 of them, but that's quite a lot of information. The cluster IP, we do a quick recap. Cluster IP service, that's an internal load balancer, as we can describe. The node port service, I like to describe it as a do-it-yourself LB to give an access to your for your pods. We've seen the load balancer service, that's a managed load balancer on a layer 4, but it's just on layer 4. And if you want to have more settings and more configuration, then we have the Ingress controller on the layer 7. So I think it gives you a good overview of all the different components you could use to expose and load balance your traffic inside and outside. Not outside, but in front of your Kubernetes infrastructure. And now it's a good time to give the stage to David so he can take over and show you all of these different concepts, experiment in a real infrastructure. If you have any question, feel free. We'll answer it at the end. David, are you ready?
Yes, right. I am. Thank you, Alex. Okay, so let's put in practice what we just saw with Alex at the moment. And as you can see, we can go into deep technical stuff. So if you want to go technical, do not hesitate to let us know in the comment, or if you want to stay a bit higher level, the same, do not hesitate to share with us. So I don't hammer you with a lot of information. So for this demo today, we're just going to play with the concepts that Alex showed, and we're going to try to do something a bit more realistic with it. So the idea is that we're going to start by deploying a very quick web application. So it's just going to be a web server that I'm going to use to send requests and see the responses. Then we're going to look at the different services concept that Alex introduced. So we're going to show how to access the application through a cluster IP service. Then we're going to publish it externally using a node port service. Then we're going to improve things using the load balancer, which is a bit more appropriate for exposing services outside. And then we're going to, I would say, deploy a more realistic application, something that would look like a proper website, but of course with mock-up backends. And we're going to play with the concepts of Ingress and load balancer with this. So this is where things are going to get goofy, because it's also my first time playing with Livestorm as an admin. So I'll now share my screen. Here it is to show you my demo setup. So for this demo, I'm using a Kubernetes cluster that I created using Capsule. So it's a simple cluster that has one pool of nodes with 3 nodes in the pool. So as you can see here, I have 3 nodes. To interact with the cluster, I'm going to use a mix of both the console and my terminal here, where I have a tool called K9S, which is a command line tool, a visual command line tool that allows me to see what's happening in the cluster. So it's something that's going to be useful. As you can see here, I have my 3 nodes visible, and I can dive into each object and see its definition and all the information about them. So this is what I'm going to use for the demo. Okay, so the first thing is that I'm going to deploy a very simple application with 2 containers. So for this, I'm going to use a deployment. And here is, whoops, I just copy my command line so it's faster. Here is my deployment. As you can see, it's a Kubernetes deployment. So it means that it's a resource that is going to deploy 2 replicas of my pod. And this pod is a simple Nginx server that is going to respond to my requests. So in the cluster, once I deploy that, I'll have 2 of these. So let's go and deploy it. Just to show you how it works, I'm looking at the pod in my cluster. At the moment, 0 pod in the namespace I created for that demo. Let's just apply it. It's created, and now I have 2 pods appearing in that cluster. I will now show you how to reach these pods. So as you can see, they all have an IP address, and as you can guess, if I try to reach that IP address from the outside, it will be a problem. You see, I will not wait until it times out, but basically I cannot access it. These IP addresses are the pod's IP address, and they are internal to Kubernetes. So only things running in Kubernetes can access them. Just to show you that, I have a second window open here, and I have a pod that I deployed earlier that is going to be my admin pod to send comments from inside the cluster. So let's connect to that pod and run that same request. And here you can see I have a response, and this response is showing me the pod address. So it's the one that I requested. And if I send the same, it's always going to be the same pod responding. So now, if I take the other one, just as a proof, now you confirm that it's still the same, the other pod now that is responding. Okay, so now I have a way to communicate with my pods, but as you can see, I need to know the IP address of the pod, so it's not really convenient. And as you know, pods IP addresses are ephemeral. So if the pod dies and is recreated, it'll get a new IP address. And if I based all my application logic on knowing these addresses, I will be doomed. I'll have to reconfigure everything. So in order to simplify that, I will deploy, and let me show you that here. I will create a service that is going to be exposing my 2 pods, and it will be a cluster IP service, as Alex explained. So this is an internal service that will provide me with a single IP address and a domain name to access my pods, and it will automatically balance traffic between the pods. And to show you that, I'll use my admin pod to connect to that service and show you that I cannot access it through from outside of the cluster. So let's create that service. So here is just to show you. Oops, sorry, I need to go back to sharing the right screen. That will be better. So I am using this manifest, and as you can see, it's very simple. It's just creating a service with the proper name, cluster IP service, and it will be fronting the pods that have the label my app. So luckily, I added the label my app to all my pods I deployed previously. So let's go and deploy that that service and see what is happening. Yes. So if I go back to my Kubernetes cluster and I'm looking at the service objects, I see that now I have my service that is available here, and this is its cluster IP. So that's the famous IP that is only accessible from the inside of the cluster. So if I take that IP address and I go back to my pod, so here I'm inside the cluster, and I curl it, this time I get a response from pod with the IP address 19. If I do it again, so going to be again the same one, and then it changed. So now it's the other 222 that responded. So the concept is that cluster IP is balancing the traffic between the two pods for me. So that's the cool thing, because now I do not have to take care about knowing the pod IP address. I just need to know the service IP address, which is much more, which is not ephemeral. So it's much more convenient. If I try to do the same thing from outside of the cluster, so here I'm on my computer. Whoops, sorry, I didn't take the address. Here is the address. So as you can see, I cannot connect to it. So it's really not accessible from outside of the cluster. And just to show you one last thing, this service also has a domain name that is created automatically when I'm creating the service, and it's only available inside the Kubernetes cluster. So this is the domain name for my service. So you don't even need to know the cluster IP. You can use the domain name to contact the pods. And here again, you will see that it will balance between these two pods. Okay, so now we have showed the power of cluster IP service, but as we seen, it's not available for users outside of the cluster. So in order to make this available, let me now work on creating a new type of service. It's the node port. So the node port, as Alex explained, is going to basically use a dedicated port on each node of my cluster. And this means that if I'm contacting any node of my cluster through any of their IPs and using that port, the node is going to pass the traffic to that service, and the service is going to balance traffic to the pods. So here I'm going to create a node port service using port 32080, and we're going to look at how things are happening. So to do that, here is another manifest of a service. So this time, interesting things is that it's still very simple, but this time I created it with the type node port. And I said, I want to use port 32080. So let's create that service and see what's happening. Up. Now it's created in my cluster. And here's my service. And as you can see, it also has a cluster IP, but on top of it, it has the port I requested. So the node port is really building on top of the cluster IP. And to show you how it works, basically here I will try to access. So as you can see here, if I'm trying to access this IP address up from outside of the cluster, it's the cluster IP, it doesn't work. But we said that it's published it through the nodes of my cluster. So if you remember, I have 3 nodes with 3 different IP addresses here. So what I'm going to do is that I'm going to send the curl request directly to these IP addresses, and using the node port that I created, so 32080. So here is a command line. Sorry, it's a bit more complicated because I just filtering to get the server address field, so you can see which pod is answering. So here is my first node, And as you can see, I have an answer from port 19. Whoops. If I do it again, at some point, yeah, it will move to pod 222. And to show you that this is really published on all nodes, here is the request from another node. You see a different IP address in my request. So if I do that, I still have an answer. And if I send the same request to the third node, remember, I'm outside of the cluster here, and it works. So what you see here is that the service is published on all the nodes of the cluster, independently from a pod running on that node. As you can see here, if I look at the pods, there are just 2 pods, and I have 3 nodes. So it means that there is 1 node where there's no pod running on it, and the 3 nodes answered. As we showed, it's the limit with this is that, okay, you can access your service from any node, but the question you'll have is then, okay, how do I choose 1 node for my different customers? And then there's no easy answer. So in order to help you with that, at Scaleway, we're basically creating something called a wildcard DNS. So it's a DNS name. Here is the DNS name that is basically going to return the IP address of any of your nodes. So it means that if you want to have a single address to access your service, you can use that wildcard DNS and the node port that we just created. So just to show you that, here, I'm going to send a request to that wildcard, and I'm getting an answer. So the problem with that is that using DNS for load balancing is not really perfect. The main reason is that DNS records have TTL. So if your node crashes, the TTL might keep the record for some time and keep resolving to that failed node. And in the end, this is an impact for your end users. And as you know, it's always DNS. I know you've been debugging application, and it's always DNS. So if we want to go a bit further and do something smarter, we can actually use a load balancer. So I'm not going to configure one right now, but what you could simply do is go into your console and create a load balancer and configure it to balance traffic to your different nodes, and using the node port that we created. So that's one way. Or you can create, if you want to manage it completely on your own, you can create your own instance, install your load balancing software, and manage everything. The benefit of using our product is that it has high availability. So it means that you have the single IP address, and if the balancer fails, another takes over, and you do not have any disruption for your end users. So this is really the point of using a managed service. So let me just now remove that service and move on with the rest of the demo. So as I said, we could use a load balancer to expose our service, and it would be a bit annoying because I would have to configure it myself and manage it manually. So if I add more nodes, I have to add them as the backend of my load balancer. If I remove some, I have to take them off. So it's a bit annoying. So Kubernetes has this notion of, oops, sorry, I just did that. Kubernetes has this notion of load balancer service. So it's a service resource with type load balancer. And what happens when you use it is that the Scaleway Cloud Controller Manager is automatically creating a load balancer, so an external load balancer for you, configuring it and maintaining the configuration. So this is what we show here. This service with type load balancer will create a load balancer that you can see at the bottom of the slide. And this load balancer will rely on the service inside that is also a node port. So when you create a load balancer service, it actually creates a service with type node port and cluster IP on top of it. So it publishes the service to all the nodes, and we create a load balancer automatically that is using all the nodes with the proper node port as its backends. So let's play around with that. Here, you'll see that I have, if I go to my, let me clean up a little bit the screen. I have now another manifest for you. that is basically creating very simply a service now with type load balancer. And again, I keep it very simple and I'm exposing my app pods. So let's create that and see what happens. Up, command line, here I am. So if I go into Kubernetes now and I display my services, now I have a new service and you can see it has a cluster IP, but also an external IP. So this is the IP address that I can use to contact the load balancer. And just to show you what happened, now if I'm going back to my console and just, whoops, thank you. Now you can see I have a new load balancer that appeared with a crazy long name. It has been created automatically. And if I go in there, what I can see, it has a public IP. It has a front end on port 80, which is the port that I specified in my manifest when I created the service. And it has a backend that is running on port 3691. So this is because the service has been created automatically and Kubernetes gave me a port. I didn't request the port 3280 this time. And if I look at it, it has 3 servers, which are my 3 nodes. So this all happened automatically, so you do not have to manage any of these things on your own. And what will happen is that if we add more nodes, they will be added automatically. And the load balancer is also performing health checks, so it will avoid forwarding traffic to sick nodes. So it's really convenient. One thing you need to know is that this resource is automatically managed by Capsule. So if you see it in the console, please do not try to go and modify it, because the next time you're doing something in Kubernetes, we will erase your configuration. You would not understand what happened. So this is really here to show you the configuration, and you shouldn't be modifying it because your modifications are not going to be persisted. So now, as you can see, I have this load balancer IP address. And if I just curl this one, now I'm getting a response from one of my pods. And at some point, yeah, you see it switches. So the load balancing happens both in the load balancer, picking a node for you, and then inside Kubernetes, once you're inside the node, the service is picking one pod or another one. One thing that is very interesting with load balancer service is that you can use the Kubernetes resource, the service resource, to pass advanced configuration to the load balancer. So let me just delete that service and recreate it with a different configuration to show you how this works. So the typical thing, now I remove the balancer, the typical thing you expect from a balancer first maybe to book an IP address. And if you want to do that, let's edit this service to show you how we would do that. We can simply reserve an IP address by adding a line to our specification, which is this one. Up, going at the end here, and I need to indent it properly. So here I'm telling the load balancer that I want this IP address specifically, and this is one that I already booked. Why I would like to do that? It's because probably I have my DNS record pointing at that address, and this is the one I want to use instead of getting a random one. The other type of thing we like to do with load balancer is passing the real IP address of the client making the request. And you can do this because the load balancer is actually going to intercept the request and forwarding it. So you will see internally as the request coming from the load balancer. So if you want to know who is the original user, and because you need that in your app, you can enable proxy protocol in the balancer. And in this case, you're using an annotation to enable this. On Scaleway website, we have a documentation page listing all the annotations that you can use to configure the load balancer. So if I recreate my load balancer again, this time with this specific information, so now you see it's creating. The IP address will be assigned. So this is the one I requested, 236. And if I go into my console here, here I have a new load balancer, and you can see it has the IP address I specified. And if I go to the backend, you see now that I have proxy protocol enabled. So it's a really powerful integration because from Kubernetes, by creating resources, you can configure your load balancer to behave as you want. So it's something you should use. And the benefit of it is that this is, as you know, declarative configuration. So it will enforce this configuration anytime an event appears and the cloud controller manager has to reconfigure a load balancer. So it's persisting your configuration. Right. Okay. So now we've seen these three theoretical examples. Let's try to do something a bit more realistic. So to do that, let's go back to the slide. We are going to try to build something a bit more realistic. So in this case, I want to be building a website inside Kubernetes. And on this website, it will have two applications running for the website. So let's say this website is available at www.thedudes.fr. It's the website of a rock band. And inside this website, they want to have a blog where they're going to share news, and they want to have a shop where they're going to sell merch. So not setting too high expectations. These are going to be phony apps, so you're not going to have a nice UI when I deploy that. But basically, how do we want this to work? We want our users to access the www.thedudes.fr website, and if they enter the /blog path, they want to end up on the blog, and if they enter the /shop path, they want to end up on the shop. And they want to have one host name to access everything, and one with one entry point only. So if we try to do that with what we learned so far, we would use potentially load balancer services. So we would deploy our application as a set of pods for the blog and the shop. And for each of them, we will have a service with type load balancer to expose them outside of the cluster. The problem with that is that you end up with two load balancers, so that's costly, and two different domain names. So you don't have the www.thedudes.fr/blog or /shop. You have blog.thedudes.fr, for example, and shop.thedudes.fr. And this is not really what we want. So luckily for us, Kubernetes is providing a solution for that, which is called Ingress. So before I go there, how are you guys feeling? Are you all right? Did I already hammer you with too many information, or are we good to go and dive a bit deeper? I realized I'm asking that, and you're so infinite.
We have good feedback.
The chat.
I think it's okay. We can go further. People seems to be hungry.
Okay, they're hungry for more. So let's go for that. Okay, so luckily for us, Kubernetes has a solution for that. And it's, as Alex said, the Ingress. So the Ingress is a resource that is deploying a layer 7 load balancer. So everything I did so far with the load balancer is happening at layer 3 and 4. So it's just going to be some sort of a pass-through that is routing through the nodes based on their availability. Now what we want to do is something a bit more complex. We want to be routing things based on the path that is requested in the HTTP request. And this is done using the Ingress. So the Ingress resource allows us to define these types of routes. If I'm contacting www.thedudes.fr, we can decide that everything starting with /blog is going to the service, blog service, and everything with /shop is going to the shop service. And this is very important to understand. It's that the Ingress is a load balancer balancing between services inside Kubernetes. It's not balancing between pods. So the load balancer is going to forward traffic to the service, and the service is going to do the load balancing between the pods. So let's look at how we would build that inside our Kubernetes cluster. Well, the first thing is that though the Ingress resource is built inside Kubernetes, you have to install an application that understands it. And this is called the Ingress controller. So in Kubernetes, we will first install an Ingress controller, and I will do it through the console using the easy deploy feature that has I would say, created applications that we can use. So here, if I'm hitting deploy an application, I can deploy it from the application library. If I'm looking for Nginx, here it is, Nginx Ingress. So you see, here it gives me access to the default configuration. So this is using Helm, and these are default values. I want to be customizing it a little bit, and I'll be covering that if you need at some point to give you a full view of that. Let's do this way. Let's reserve an IP address. So I'm using the same one, and it's already set with my DNS. And let's deploy that. So it's going to be called Nginx Ingress, and I have created a special namespace for that. Very creative name. Again, let's deploy that. And while we do that, let's go into our terminal and see what's happening. So I have my Nginx Ingress here namespace, and you can see that I have my Nginx pods that are being created. So when we're deploying it, basically, we are creating a pod on each node. That's the default way of deploying it. And these pods are going to host an Nginx server that is going to be our layer 7 load balancer. And now, as I will deploy an application to make use of it. So here is my application. It's going to be a little bit more complicated than the other manifests I've been showing. So this one is, but it's still simple, you'll see. I'm creating first a deployment for the blog that has 2 containers inside, 2 replicas, I'm using a specific image I created for the opportunity. Then I'm creating a service for the blog that is exposing the pods for the blog application. Now I'm creating another deployment that is going to create also 2 pods for the shop, and it uses the same kind of image. And I have a service in front of it, so it's really the schema I've been showing you earlier. And lastly, I'm creating an Ingress resource, and Ingress is telling me, okay, I'm listening for things for the www.thedudes.fr domain, and everything that starts with /shop is going to be forwarded to the shop service, and everything that starts with the /blog is going to be redirected to blog service. And I'm exposing everything through port 80. So let's deploy that thing. Here it is. Everything has been created. So let's go into our namespace to show that. So I have my blog pods. Oh, I forgot to delete this one. So sorry, it's going to be a bit of noise. I have my shop pods. If I'm looking at my services, I have my blog and shop service. And because Nginx Ingress is going to sit inside the cluster, we don't need to have these services public. They can just be cluster IP services because it's going to forward requests from the inside of the cluster. So here is my application. And if I show you, I have my Ingress resource that has been created with the rules that we've defined here. So if everything is correct, we should have cool results. So let's head up to the dudes/shop. Whoops, with the third W, it would be useful. And here you can see I have the welcome message. So sorry for the disappointment of not having something sexy and cool looking. That's all I'm able to do in web development. So here we are at the shop. And if I do the same with the blog, here I'm ending up at the blog. So mission accomplished. The Ingress controller helped us with that. Now, a question for you all. How deep do you want to go? Because I can give you a bit more insight on how we can access this. Okay, I think you guys are ready for that then. Okay. So bear with me a second, and please don't be mad at me if this is brutal. So how does that work? I've been creating an Ingress layer 7 load balancer inside the Kubernetes cluster, and basically I still need to access that cluster to access that load balancer because it's running inside the cluster. So what we actually did, so this is a better view of what's happening in my cluster. I have my pods with my services, and the Ingress resource is actually just a resource. And as you saw, when I deploy the Ingress controller, are these 3 pods that have been deployed, running on each node. And if I want to access these pods, I have to create, and this is what's done automatically by the Ingress, by the installation procedure. It creates a service in front of it with type load balancer, which is then provisioning an external load balancer automatically. So you will have different ways of exposing your Ingress controller, but the best way is to use a load balancer because you'll have everything managed for you. So you just get the key and you're done with it. So that's typically what's happening behind the door. And just to prove you that, here is my, let's go into my Nginx namespace. And I can, so these are the 3 pods that I've been talking about running on each node. And if I go into the services, I sort of already spoiled it. I have a service called Nginx Ingress Controller service. And as you can see, it has type load balancer. It has an external IP, which is the one I requested. So this is how you're exposing this famous pod to the outside world and accessing it. So this is why just saying I'm deploying an Ingress to expose my service is not accurate, because you need to expose the Ingress outside of the cluster too. So you need to rely on a load balancer type of service or a node port service or some other tricks. So this is basically what I had. And for the most courageous ones, I'll just make your head explode with this last slide showing you the full view. Because actually what's happening in there is just that I'm showing the nodes on top of it. So as you can see, the load balancer is balancing traffic between the nodes. The node ports are forwarding the traffic to the Ingress controller service. The Ingress controller service is forwarding traffic to any of the Ingress controller pod. And the Ingress controller pod is doing the layer 7 load balancing, forwarding the traffic to the cluster IP services internally. And the cluster IP services are forwarding them to the pods. So if your brain is still able to get all this information, with this picture, you know exactly what's happening and how things are working inside Kubernetes. So that's all I had for you today. I hope it was helpful and unlocked a couple of doors in your Kubernetes journey. And now we have a couple of minutes for question and answers.
So now, David, you have to release the first single of the youth.
That's it.
So we have some question. If you would like to upvote, it's because I'm not sure we have time to answer all of them. Yeah, we have approximately 10 minutes. The first one is: do you have access to the question, David?
Yes.
Yes. So what Ingress controller does Scaleway recommend or use by themselves or by ourselves?
Okay, so that's a tricky one, actually. As you saw, we have both traffic and Nginx in our easy deploy app library. So personally, I know how to use Nginx, and with the resources I have on the internet, I can troubleshoot it. I know traffic is very popular too, and have a big community and a lot of resources. So to me, these 2 options are really valuable. So you can use any of them. My preference, because of what I know, would be Nginx, but that's personal.
Okay.
But just as a clarification, you can deploy those 2 from the easy deploy. But if you want to install other Ingress controllers, it's absolutely open. You can do it using Helm or whatever deployment tool you want. You do not need to have it in easy deploy to use it.
Next one, we have Kevin ask, We have a service, load balancer type. When a node is upgraded, some request time out until the node is fully operational. How to avoid this behavior? How to avoid network interruption during node upgrades? Do you have any idea?
So in this case, I do not know the full configuration, but usually this is why you need to have more than one node in your cluster, because then the load balancer in front will detect that the node is being rebooted and not available and will not forward traffic to that node and pick another one. So first thing is to have several nodes and to make sure that you have health check enabled in the load balancer. So this should happen by default using TCP health check. So the load balancer is going to try to connect to the TCP port specified in the backend. And normally you should be good with that. If there is still a problem with that, probably we should have an offline discussion to see if there is something in your configuration that is making this not working.
Philippe, is it possible to route to external addresses, for example, for serving static files from S3?
I assume that this is for when using a load balancer type of service. So in the context of using the load balancer service, no, you cannot do that because the load balancer service is entirely managed automatically by the cloud controller manager. So as you can see, the service object resource in Kubernetes doesn't give you these type of fields to do this kind of configuration where the service is going to balance outside. For this, you'll need to have a load balancer that you're installing on your own and managing on your own in front of a Kubernetes cluster. It cannot be automated this way. The same goes with the Ingress, because the Ingress is supposed to balance traffic only between services in your Kubernetes cluster. So this type of configuration would not be possible if you're using the load balancer service or the Ingress. But if you're configuring your own load balancer in front of Kubernetes, you could do that, yes.
Yep. Thank you.
Maybe just, what I was thinking, in this case, if you wanted to balance maybe to another one, you can also take care of this within your application and respond to the request with a 302 redirect, for example, in HTTP world, where you would be redirecting based on from your application directly. That's just a workaround.
We have a question about public IP and a VPC between LB and nodes. I think it's in the future we'll have this product to offer with Kubernetes. But for now, you have a public IP with your node.
Yeah, it's not available right now, but don't worry, it's in the roadmap.
It's next month. Next month, you will have a public beta on this product. So you need to be patient. Just 1 more month. Which question now? Alexander, yeah. My question would be, at which point do you think it's relevant to have more than one LB? How can you monitor the health of the LB to know where they are under pressure, heavy pressure? When it will be the right time to have one more and split DNS traffic to the LB? So how to monitor the health of the LB, actually, that's the question.
Okay, so you have several answers to that. The first thing is that you I don't know if you're aware, but the load balancer works by sizes. So you have 4 different sizes of load balancer from S to XL. And you can configure the one you want in the service resource in Kubernetes. So by default, it creates an LB with S size, but you can specify to have a larger size. And the LB itself has an upgrade feature that allows it to transition from one size to a bigger one. And this is without service interruption because we're using the failover to do that at that moment. So it's something you can use to support more traffic. If you want to monitor your load balancer, so we are currently working on integrating our metrics into Scaleway Cockpit. So Scaleway Cockpit is at the moment in beta. It's an observability solution that provides you access to metrics about all your products, and the load balancer is going to be integrated in there. So you'll have nice Grafana dashboard showing you your load balancer, and you'll be able to monitor its state. And we'll also be providing alarms to let you know when the load balancer is potentially overloaded and you should consider upgrading that. So this is all work in progress. We have first beta dashboards available, and I think the GA is targeted in a couple of months. So you will have everything included in there.
Yep. Next question. If the dude.fr is a white mark, can I have multiple domain? I need one load balancer per domain, or do I need several load balancer? What is your domain limit per load balancer? How do I handle SSL or TLS?
Okay.
There is another question about that. Does the managed load balancer support TLS? Should that still be configured on the Ingress? Yes, it's linked.
Okay, so whoa, it's a mouthful. Okay, so in this case, the dudes.fr is my top level domain. So it's my apex domain, as we say, and you can create as many subdomains as you want. And in this case, when you have subdomains, you can either create a different load balancer service for each subdomain and have the IP of that load balancer service, the IP of that load balancer against that subdomain. Or what you can do is that you can also use the Ingress. I haven't shown this example, but the Ingress resource can be configured with multiple domains. So it means that you can still have your different domains managed and balanced by the Ingress controller to the different services under a single load balancer, and you'll just have to adjust your DNS to make sure that all your subdomains are pointing to the IP address of that single load balancer. Related to SSL or TLS, yes, it is supported, and it is also supported in the managed offering. Just one thing that you probably want to consider is that in this case, your load balancer is acting more at layer 3 and layer 7. So it will be a pass-through. So it means that the SSL and TLS certificates should be handled by your Nginx Ingress controller, by your Ingress controller. So this is the one that will be presenting the certificates. You can, of course, configure if you want to have some sort of SSL how do you call it, bridging inside the load balancer. If you require it, maybe there are some specific cases where it's required, but usually in the context of Kubernetes, you just want to have a pass-through and no headache with that. But if you need, yes, it's configurable through the annotations in the Kubernetes service. And that's, I think that's mostly all the question. In terms of domain limits, I do not know exactly. I know you can have up to something like several hundred certificates, but domain limits, I don't know. I don't think there is any.
Wim asked an interesting one. Is the Ingress controller is a single point of failure, or is it HA?
So it's completely configurable. So it's the point of Kubernetes. So as you saw in my example, I deploy the Ingress controller with the type daemon set. So a daemon set in Kubernetes is a resource that makes sure that I have a pod of that daemon set running on each single node of my cluster. So in my case, I had 3 nodes, I had 3 pods. You can deploy it as a deployment if you prefer and specify a number of replicas. So Kubernetes will make sure that you have that number of pods running all the time. And this is your high availability. Because if you remember, this application is exposed behind a service, and the service is going to guarantee the high availability. So the service is actually doing all the health check internally in Kubernetes and removing pods that are not ready or not healthy, from the balancing. So you have de facto high availability. But if you want to have high availability, you need to make sure that you are deploying your Ingress controller with a type that has more than one replica. Because if you have only one replica, if this one dies, Kubernetes will recreate a new one. But during the recreation time, you will have access failures. So if you start your Ingress controller with at least 2 replicas, you should be good and completely highly available.
Yep, we go to the end. I have here one using Scaleway UI to deploy Ingress controllers. It's very imperative, okay? It's good to be honest. How do you handle subsequent upgrades of the underlying M chart? I know I don't have any details to give you right now because I don't have it top of my mind, but I can come into contact with you with Oliver to give you the answer, to have a very precise answer, but I know we have this this implemented for sure. I will send you an email. I think there is a last one. Yeah, this one is already done, about John Doe. In this case, how to expose a log stash on a custom port through an Ingress Nginx behind a load balancer with a proxy protocol v2 without exposing log stash. I think it's an idea of use case. Huh? Yeah, it's an idea of use case. What do you think, David? Is there any
log stash on a custom port? Okay, so in your case, that's a whole chain. Actually, drawing it would be easier. So basically, you will create your Logstash app, probably using a deployment or a stateful set, I guess. And you're exposing Logstash using a service, and you keep the cluster IP type of service. So this one is going to be internal only. And because you have the Nginx Ingress controller inside the Kubernetes cluster, it can use this cluster IP service to contact Logstash. So remember, if you're using an Ingress and you want to expose Logstash through the Ingress, it's the Ingress that is going to access Logstash on behalf of your users. So if you need to know, if you want to have the proxy protocol, you'll probably need to enable it on all steps of the chain. So in the load balancer, so that the load balancer uses proxy protocol to forward traffic to the Nginx Ingress controller, and inside the Nginx Ingress controller to forward traffic to your Logstash using proxy protocol. And in this case, you also need to make sure that your Logstash is configured to listen to proxy protocol, because the proxy protocol is an explicit protocol and only listens at proxy. So proxy protocol is just adding the IP address of the client in front of the TCP session establishment. And it means that the server listening to that needs to be aware of it. So if you're sending proxy protocol to a web server that is not configured to listen to proxy protocol, you will not have an answer. So typically, this is explained in our documentation on the website. If you want to configure your load balancer to use proxy protocol with your Nginx Ingress, you need to make sure that you're configuring your Nginx Ingress to support proxy protocol on their front-end side. And this is done through annotations in the Helm charts also. So if you go to the Nginx Ingress documentation, in the Helm chart documentation, they will tell you all the options that you need to pass to deploy Nginx Ingress with proxy protocol. And you also have annotations to put so that the load balancer is configured to use the proxy protocol. But yeah, so in the end, Logstash is going to be exposed through Nginx only, because your Logstash service is only cluster IP service inside the cluster.
Okay. Okay. So good. We come to the end. Nera, do you have a?
I think we answered most of the questions. If there's some questions that we didn't get to, we'll double check and we'll make sure to email you after the webinar.
Sure. So we have a small gift to give to for people who don't have a Scaleway account, 200 euros as a voucher value. with the code that you can copy paste. Maybe just write it write it here on the console. If you have more questions to us, feel free to reach us on community Slack community. We are available and always happy to speak about our product. And we have more content if you want to go into details. We have a blog post about this topic. We are going to publish. We're going to publish in the next week, and a YouTube video about specifically about the load balancer part, but it's not the same level of details. Otherwise, well, okay, we just forget to update the slide, but yeah, otherwise we are present at the Kubernetes Community Day, beginning of March. I forget to mention in the webinar, but if you want to have a chat with Scaleway, with us, with all the Scaleway team, we'll be happy to meet you there. And I think that's it for us. If you have any question, or maybe it's the last time. Nera, David, if you want to add something.
David, anything to add?
That's all good for me. Thank you everybody for listening to my very long speech.
Kubernetes Community Day, that's the event in Paris. That's the 7th of March. I'll write it down. Sorry for my English. Yeah.
Yeah, that's it from us for today. Thank everyone once again for joining us. As we mentioned in the beginning, we will share the recording this afternoon, so you can rewatch the webinar again and let us know if you have any additional questions. Thank you and have a wonderful day.
Thank you. Have a good one. Bye.
Goodbye.
Thank you. Bye.